here to introduce our first speaker, Mark Marlin of Google. And I'm going to read your full talk title because I think it just says everything that it needs to say. Live upgrading thousands of servers from an ancient Red Hat distribution to a 10-year newer Debian-based one. And I am absolutely thrilled to hear how you did that live. So,
I thought you wanted to know why I did that.
Well, that too. Tell us more.
All right, so this is a 1 hour talk. We have 25 minutes. So I'm going to have to chop through some of the slides a little bit. Obviously, the paper has more details. The slides themselves are also, I like the talking slides, which means you can actually read them if you weren't here, or if you don't forget. I forgot everything. And really the point of the talk is kind of to encourage people to think outside the box a little bit for distribution maintenance and upgrades. I'll give small samples from you to see how you're doing it. But it's, it's something that gets ignored until it's a problem, and then depending on how long you ignore it, it becomes a bigger problem. And you multiply that by the number of machines. Anyway, so actually before I even go, let me do a quick couple of questions for the audience. Has anyone actually read the paper and had a bunch of questions?
Well, no questions.
No questions, good, okay. Okay, but as long as it's not a bunch of questions, I'll spend more time on this, and then we'll do questions at the end. If there's something really obvious in the middle, you can interrupt me if you wish. So, upgrades. One way to do it, do an install. You wait for a long time. You maybe put a few security patches, and then 3 years later, or whatever long you waited, and you say, we should probably upgrade. So then you install the new CD, and you start migrating stuff to new machines. That's one way to do it. The other one is some distributions still kind of have an online upgrade system, which sometimes works, sometimes doesn't. There's other ways. Are there big ways that people are using that I haven't mentioned? Or is it really just those two? Okay, mostly those two. So this is about doing an option number 3. So very quickly on Google, I've been doing distro work for way too long because I don't know any better on Linux, and doing upgrades in different companies, Google being the last one. When I joined, like every other company, they had a bunch of machines. Linux CD got put around, installed the first machines, then kickstart image. Then you start having to install patches on top. SSH loop is, of course, the first way people do it because, well, it's easy but really not scalable. And eventually you say, oh, okay, that's not going to work. Let's just reinstall the new version of whatever's out today. This is great when you have 1,000. Well, it's actually not great when you have 1,000 machines, but it gets worse after that. So updates. Well, updates, obviously, there's only so many ways to do them, right? The SSH loop is one way. The other one is you're running a apt-get upgrade, or you have an equivalent from cron. Actually, out of curiosity, who's running updates by just running the package manager from cron? A few, okay. Are those your own packages, or you just pull the security packages from upstream and you hope they work? A little bit, half and half. Which, it is the easy way, don't take it wrong. I've done it until, well, actually, no, I never really trusted it. But the point is, from time to time, they make an update that just breaks in the config file. It updates at 2 in the morning when you're sleeping, and then the next morning, everything's done. So I'm not a very trusting person. I don't like doing that. So then it means you can do the same thing with your own packages, which means you have to repackage and check everything, move it from the outside repo to the inside one, and use that way of pushing things. That's not a reasonable way to do it, by the way. Anything that's push-based to servers is flawed, right? Because the servers are going to be down. When you push something, 2% doesn't get it. You can keep track of it forever. So really, you want machines to pull, and there's many ways of doing that. So I'll just keep going. So yeah, before long, like this, and really at night, you're hoping it's going to be like this, which it did become, but it took a long time. So the third way that not many people use is file-level syncing. I first saw that at a company where they were syncing workstations to keep them up to date from a golden image. I was like, that's kind of interesting. Of course, you have to exclude a bunch of files, like network configuration, stuff like that. But if you do it intelligently, it actually works somewhat. Except that rsync is not meant to have 50, 100,000 workstations rsyncing against a server. I mean, by the time you're running a few, it's really not scalable. But the idea actually is not that flawed. I know it sounds crazy, but bear with me a little bit. So, long story short is we wrote an rsync-like program to do effectively the same thing with some I/O throttling and a little bit of extra code I'll get into. The throttling is actually not for the server as much because we can add more servers. It's more that you don't want the clients to be serving data and slowing down because now they're churning on their disk trying to update why they're serving customer queries. You could take them down, of course, while you're doing that, but it's better if you don't actually have to do it at all. So yeah, the question is, wait, rsync, that means they're all the same. Actually, yes. The root file system would just make it all the same, except again, a few configuration files. And that way, one size fits all, right? Model T is any color you want and it's black. Well, it's not a bad way of doing things, at least when they work at scale. And then the applications, of course, not all servers are doing the same thing. The applications go into a different partition, and they don't use the package management system. So whether it's dpackage or RPM, they don't get to use that. They don't get to touch the root partition. And if you somehow use it, you have root and you have SSH, which is not something you're supposed to have. But assuming you have that and you touch stuff, it can get reverted behind you. So that way it gets back into a known state. So now, okay, that's a good way to push a few package upgrades. Let's say your security updates, you go to your golden image, you install that update on your golden image, and then it will sync to your feed. That works, right? But it doesn't work when you've been doing this for years and you're still running Red Hat 7.1 and it's, shall I say, 2009-ish or 2010, something like that. Turns out, yeah, it was a bit old. Of course, you know, it's not like the whole system worked with 7.1, they had a bunch of patches on top, but it still was at the core 7.1. At that point, you're like, ooh, well, if I update, the entire system will change and nothing will work. So no one wants to do it because it's going to break everything, right? The other reason why it didn't happen for so long was, well, it's really Linux was just a boot system to bring up our app management system, and that's all self-contained, running its own script. Our applications have their own dependencies, so they did not rely on the very old system. It was just really a bootloader. And that's one more reason why we stayed with it for so long, because it actually wasn't a problem. Well, not too much, that is. So I talk about this very quickly. Package upgrades, golden image. I'm just going to go quickly, otherwise I can't do all the slides. More importantly, pre-post installs. So if you're doing a sync of the same image, now think about installing SSHD. If you install SSHD, it will, after installing the binary, generate a host key for that machine. Well, obviously you can't just sync the same host key to every box, or you could, but that wouldn't be a great idea. Same thing with Lido. It has to be run separately in each machine for obvious reasons. Any post-install that restores a daemon, well, that's not going to work, right? So basically, our rsync replacement program has a concept of trigger, which means if this file in the file system gets touched, then after everything is done syncing, I run this in script with a restart. And that's how we take care of restarting binaries, generating files that are different for each machine. There's actually not that many SSHs, the big one I can think of right now. And I already went there. How did that work out? Well, it actually worked a little bit too well. So that we didn't have to do much except keep the system and put patches on top. So, as you probably can guess, it's not a forever solution. So we have to do an upgrade to something much newer and doing it live, because we don't want to reboot machines unless we're putting new kernels. Also, we don't want to take them down and take a long time to migrate things off and have two systems running and very slowly migrate because we're not sure, right? I mean, it's not a reasonable way of doing things, but we decided that we didn't want to have a split system where we have applications that could have, you know, let's say you have 2% failure rate. Now you don't know if it's 2% because of the new OS or the old OS, so now you have to segment it further. And it was just a lot of work, and our SREs were not very interested in that solution. They really want to have the same image everywhere. meaning the current one and the new one that we're pushing. Of course, you're always in between two images, but not something 10 years old and something from yesterday. Before we go there, I'm not going to go into long details about what Linux distribution we picked and why, but long story short, it's Debian. It's mostly because at the time it had many more packages than Red Hat. Some of them were interested in having. In the previous distribution jobs on Red Hat, because I've done it on Red Hat too, I spent way too much of my time packaging stuff that didn't exist, or finding offsite packages that weren't quite right or weren't QA'd. And while Debian isn't perfect for everything, they have a better base for us to use. For a little while, we looked at Ubuntu because we had that on the workstations. At the time on Ubuntu, that part was still okay, but then it started being more, they started doing crazy things that were all nice and clean on the workstations, but not that desirable for the servers, as far as I'm concerned at least, and of course NMPads. Okay, I'm going to skip that, but basically very quickly the scripts, as you know, we have sys5 @star systemd. The one you probably don't know about as well is Debian has the insert system, which is system 5, and all it does, it takes the scripts, looks at the headers in comments, and it will rename the numbers of those scripts once, so that it will decide anything that S10 starts together at boot. And it's something that is not as fancy, but it's a big plus for us, because remember, we run this once, then it gets snapshot into the golden image, and it gets pushed to all the servers, which for us means every server is going to start booting the same things at the same time. If I'm running either @star systemd, they have different hardware, not more disks spinning up, it means things are not going to come up in the same order. Ideally, it shouldn't matter, right? Stuff is just supposed to work. In practice, when you're dealing with some big number of machines, it doesn't always work, and we really have that motto of having everything the same as much as we can. That includes the order that things boot in. So having a speed up of a few extra seconds from @star systemd was actually not really important for us compared to having a dependable boot that always was the same. Also, at the time, again, that was several years ago, I didn't think that either @star or systemd were ready, at least not for what we're trying to do. Today or not, that's a different discussion, different topic. So the new distribution, we call it ProdNG, new generation, yes. And the point really was to have everything built from source, which the other one wasn't. It was Red Hat 7.1, snapshotted as a binary image, and it was stuff on top. The next one was to have it as small as possible, which is getting harder nowadays. So it meant rebuilding a lot of things about libraries that we didn't need at the time. I'm not saying that ACLs or SLinux are bad, but I'm saying if you don't use them, why do you have them in your binary? Then the other things were, like RPM at the time decided, hey, you should have XML2 support, because if you don't have XML2, you suck. Well, I don't need that. And there was like 3 megs just for that, and I didn't need it, right? So take all the libraries you don't need. Then things like dbus, Plymouth, that just take over your boot system and doesn't show you boot messages the one time you need them. I know it's supposed to work, but I can tell you about all the times it didn't work. Just take that out, which wasn't that image not there, so that's easier. Now you have that new image. Great. So that image boots, it kind of looks the same, but obviously it's not. It was built separately from a different OS that's 10 years newer. And even if you did everything right, core utils, it was core utils before, right? Back then. Then GNU decided that POSIX was very important, and the shell scripts that didn't do POSIX right were not as important. So they fixed all the bugs and made the shell scripts not work anymore. They're entitled to doing that, but when you deal with that rate and you have 10 years worth of breakage like that, it's a very scary thing to do. You just can't push that across 100+ packages. Or if you do, you know you're going to have so many things breaking that people are going to tell you revert before you can even look at what the problems were. So we had that new image, but we knew we just can't push it like this. It's never going to work, and we're not even going to be allowed to do it to start with. So how do you decide that it's good, that it's going to be working? Comparing was actually 20,000 files that were different. And actually 20,000 files is not even a lot for a distribution nowadays. But it's obviously too many to review by hand. So long story short is, even if our applications are separate from the OS, there are still some things that are linked to it, plus our own daemons that run in there, take care of the hardware, make sure that hard drives are okay, memory, stuff like that. And those do depend on the OS. They do call shell scripts at some point. So it was kind of scary. So how do we do this? Well, in the end, I'll skip the other things, the RPing was depackaged and so forth. But the idea is we only have so many people, and that was really a small team, don't want to be maintaining two distributions for a year or more. And that's the thing I said before, we don't want to be running that. Not only don't want to be running it for a year or more, but we don't want to be maintaining both in sync, because not anything that's given to you, you have to put in both distributions and they're not the same. So that's even more work. And of course, they're not even compatible with the RPM and depackage. So really, that was not the answer. So yes, that was very tempting at some point. But really, what we went with at the end is we agreed we can't do a big switch. So what do we do? The only way to go forward is to make small changes. And I know it's crazy, but what we actually did is we took that new distribution as Debian packages, and we converted the devs to RPMs using Alien and some other stuff we wrote. And we started putting those Debian packages one by one, or a few, maybe 2, 3, 5 at a time, in that our Red Hat 7.1 distro. So you start putting you start with BC, with Ed, stuff that's not too important, and you start getting more binaries. Eventually you have to worry about the libc, and I won't go into details about libc incompatibilities, but you have to be careful with that. And then of course dependencies between packages, because dependencies don't have the same name because it's called glibc on one side, libc6 on the other side, stuff like that. But that's what sed and shell scripting is for. Pre-post installs, well, again, some of them work, some don't. You kind of try to use what works in the LSB to convert them, so that wasn't too bad. And then you start doing the upgrade. So the first thing, and I'll drive that point again if I haven't done it already, you want as few things in your server distro as possible. Don't just install the latest CD and say server. You'd be surprised how much crap you have in it that really doesn't belong. And if you have that stuff, you have to maintain it. You have to do security updates. You have to find if it's compatible. People might actually start using it, God forbid, when they weren't supposed to use it to start with. So the first thing I did is I looked at everything in Red Hat 7.1, which wasn't that big, but compared to something today's, obviously good. And look at everything we could rip out, including locales or keyboards that we don't even have keyboards on our machine, so having 1 or 2 megabytes of keyboard mappings wasn't that important. Then all libraries that we found out we still had and no one was using, so you run a bunch of LDDs and things like that to realize that packages were including stuff that wasn't actually being used. And in the end, actually, I was able to strip so many things that we did not even have any C++ left. That wasn't the goal, by the way, that just kind of happened. In terms of only graph was using C++, that was kind of a surprise. Then didn't need graph, so no more C++, one more label we can get rid of. And that's a big one. The other part I didn't mention is our root partition is small. I think the entire image fits in 350 megabytes. That includes our custom software. As if you take that out, it's probably 150 megabytes or so for the Linux bit. And there's multiple reasons for that, but when you're loading a machine, the smaller, the faster, right? When you're syncing, less data goes faster, that's also obvious. So we did the libc upgrade. Won't go into long details, but basically, except some little incompatibilities that we're able to check and fix, that was not a big deal. And then you start with stuff like core utils. So core utils, we had 1 month. All we did was just upgrade core utils and nothing else, because it was a lot of things in core utils. So go to release changes. At least they did a good job of saying what they would break. So you could scan the source tree of all our code and find the tail plus code and so forth, and saying code reviews to get them all fixed before pushing core utils. And with that work, actually, it wasn't so bad. I don't remember that we broke anything important or essential with core utils, and that was definitely with libc scary part. Now, there's little things sometimes that you're not expecting. That's why we did one bit at a time. etc Red Hat release didn't seem like a very important file, especially when the system did not look like a Red Hat system anymore. So there's a package, all it does is contain that file. So I removed it, and Yeah, well, turns out that there's actually packages that look at that one file to decide they're going to do something special. And in this case, it was some Java code that had different font handling by just looking at that one file. So the long story is, if it's there, people are going to use it, they're not going to tell you. And the only way you find them is you push one bit at a time, so when you break something, you only have one bit to revert. And you know what bit broke. Because if you push everything, how will you know what broke, right? Or it's a lot harder to find out. So yeah, basically package by package. I mean, it was a few at a time, but it took probably a bit over 2 years actually. It was a long haul effort. So yes, that's why we have patient there. Once I got a lot closer between the two distros, I had now had a Red Hat system that mostly looked like a Debian system, even though it was still running RPM. But most of the packages were not Debian packages. And we do have our own RPM packages for people who are doing software internally, and we had to do also conversions for that. But again, that wasn't too bad. And then do the opposite and give them a way to start generating devs that would be converted to RPMs. So they could switch to the new system, but still be compatible with the old one, because the new system wasn't being pushed anywhere. It was just there for you to look at and play with, but it wasn't live. So, but the idea is that programmers would start generating a new format, and then they were compatible with the old one. It's actually a lot of work to convert changelogs, because they look nothing the same. The RPM ones don't even have time zones in them. You can have multiple releases on the same day without having a time in them. But anyway, whatever. Okay, so now we're pretty close. They look kind of the same. It's a time that finally I was able to take both and do a 5 compare and see what was left between the two images. And as you may remember, the way it works is I have a golden image that's checked in as well control system, so I can do a diff between the two and do a 5x5 diff. And by that time, it was mostly changelog files and things that I could ignore, and whatever was left was actually not too much to review, and it was okay to compare and say, yeah, that's actually the same. The big part that was not, obviously, is the boot system, anything in etc, any.d, and that took several months of work to get them compatible enough and think that they would do the same, even though they were written very differently. LSB is supposed to help with that, but really not as much. And so many things were using Red Hatisms that I really just ended up putting many Red Hat functions in the Debian LSB init functions, so that stuff would just work. The idea is to make as little, create as little work for other teams, and they don't really care that we're running Red Hat or Debian. They have software, they just want it to work. So yeah, I'll just give these. So how does switch go? Actually, it worked better than I thought. Only one bug we had was one daemon was writing in var run, which was now tempfs, and the amount of data they were writing was dependent on how many drives that machine had. Because I didn't trust anyone, I made var run very small to prevent people from writing stuff in it, since it was a tempfs, and memory is very valuable on the servers. And that actually broke that daemon on a few machines. But again, that's what we do, rolling upgrades. It broke on the first percent of machines. We found it, we fixed it. They upgraded the daemon not to do that mistake anymore, and then we're able to go back and push the image. And that was pretty much it. So the images themselves are very different because the new one is now being built from scratch. I'll see how much time, I probably won't have time to go into that, but you can ask me later. Dual package system support. We actually had code to allow installing RPMs on the Debian system, and they would actually look like RPMs to RPM and look like devs to dev. It's possible. Does it actually make sense? We found out, you know what, we shouldn't be doing this, because if we give this to people, they'll never switch to devs. So at the end, I actually removed that. And we are left with RPM to CPIO, because at least people should be able to take an old RPM and pack it and install the bits. And believe it or not, it's actually 4 megabytes of libraries and dependencies just to take a CPIO archive that's inside an RPM. That was pretty sad. So that made me a sad panda. And I looked into help on the internet. And after all that, after all this, I found that, which of course is a very obvious way of rewriting RPM to CPI. It's not actually a full implementation, it's one that works well enough for what we're doing. And it's just tracking, finding the right header and DPing the CPI out of it. I really curse Red Hat for not making this simpler. Obviously, Debian did. So, lessons learned. If you have expertise, you have lots of machines, you're really better off maintaining your own distro because you have control over it. You take all the stuff you don't need. You don't have exposure to security bugs of stuff you're not running because you removed them. If things go badly, you actually know what's inside, so you understand the system before it starts going bad, which is better when you're debugging at 2 in the morning. The next one is the fewer things you have on the root file system, the fewer things the user are going to use. Therefore, when you upgrade, you're not going to break them because they weren't using them. We also use a shrewd system that gives them a limited view of the file system anyway. But even with that, the more you give, the more they're going to use without telling you. So the API was definitely an issue, and we made great efforts to minimize the API we're showing to our, and by say users, to me a user is a Google programmer who's pushing software to serve users outside. File level syncing, I know it sounds crazy, but really it recovers from any state. Doesn't matter what happened to the system. It's the same way to push an image on a blank machine than to restore it if it's been mucked with. So for me, I mean, for us, it wasn't my work, right? We just had that for a long time. It worked really well. It even allows you to do some totally insane things like switching distributions because it doesn't matter, right? You're not using the package system to sync to your machines. And I did mention that with package systems, if you've done it at a large enough scale, both RPM and dpackage will get in broken states because the machine rebooted, something happened, and then there's a lock left behind, a corrupted database, and then by then the machine will never update again, unless you log in by hand and fix it. But you don't want to do that when you have that many machines. So file syncing doesn't care, it just fixes it, right? Don't blindly update stuff from upstream. Sometimes it will be a new daemon. I mean, never mind that hopefully never be cracked. It's more an issue that there's a new bind binary, some got lazy, they just give you a new bind binary which is not compatible with your old config file, and all your name servers go bye-bye in the middle of the night or on the weekend. That actually has happened, not to me, but it has happened. So same thing, prune. You may not want to be running a distribution for 10 years. That's probably a bit pushing it. But upgrading all the time from the last Ubuntu or Fedora core, unless you actually really need that, it might not be the best approach. Of course, you all know about Rail. That's the way on the Red Hat side. Debian stable with a few testing cherry picks on top works on the Debian side. I kind of like Debian because they actually support doing partial upgrades. You don't have to do there's a new version, upgrade everything. I just upgrade one package and it takes all the dependencies it needs. Once in a while, the dependencies are not perfect, but the point is that it's supported. On Ubuntu, they even tell you, oh, you skipped a distribution, I'm not going to upgrade. Go away, right? They're allowed to do that, but that's not something that's very nice if you want flexibility of what you upgrade. So partial upgrades, yes, partial upgrades definitely make sense. And then incremental upgrades. It's more work if you have a lot of packages, but if you have fewer, doing incremental upgrades give you less surprise and fewer things to debug if something goes wrong. So I have a lot more slides and things, but obviously no time for them, so I'll just go to questions.
Let's thank the speaker.
I lied. I actually do have questions.
Could you use the mic, please?
Sure. So I have a whole bunch of them, so I'll do them one at a time, and other people can get up and do theirs.
That's okay. You close the mic, yeah.
And please, first, do not take any of these as critical. They're as being critical things. I mean, some of them may come out sound that way, but it's my own ignorance that I'm trying to
No, it's all right. I've heard it all, so go ahead.
Can you introduce yourself, please?
Oh, hi. I'm David Ely from Argonne National Laboratory.
Okay.
It's a pleasure to meet you. One of the very first things I noticed is why everything from source?
Okay, why everything from source? Good question. It's not as much that I mean, when you take binaries, nowadays you have signatures. Hopefully you're trusting that Red Hat didn't get cracked and it's not feeding you unsafe binaries. And quite frankly, if you're downloading source, you don't know that there's not a Trojan in the source anyway. So that's actually not the security aspect as much. If you're building from source, we have our own compilers with our own optimizations. So I know people make fun of Gentoo, but the point is you can update maybe with some stack protection you like that the distributor is not doing, the compiler options that work better and that they work in your compiler. So you have more, you have a bit more luxury there. The other thing is we do modify some daemons. We have custom patches in Bash, for instance, to do better command logging and stuff like that. If you don't have the source, then the time you get a patch, you're like, okay. So you get a source that may not be the source of the binary you're running, and then when you push that new one, now you're testing the patch plus the change to the source because you don't know what source you were running before. You think you do, but not necessarily. So we learned from our prior mistake, which really, I mean, the Red Hat 7.1 thing, it was just snapshotted from a binary install because that's all people could do with their time. Too few people, too much work. But the idea is now that you have source, you can rebuild everything, you know where the bits came from, and you remove all the libraries you don't need. If you're taking the binary packages, an RPM says I want XML2, which wants SC Linux, which wants whatever, you're getting all those libraries that you don't want. So if you want a small image, which I really recommend again for servers, that's the only way to go. The other thing I didn't mention in one slide is that the entire image, every time we make a new image now, the image is built from scratch by installing all the packages into a shroot and then tarring that up at the end. So every image is built from packages that are built from source, which are put together into an image. There's no more patching. It's reproducible from the ground up.
So unfortunately, we don't have time for more questions for this speaker, but you can find him in a break, though. So let's thank the speaker again, please.